Hello. Who is in
Hi,
the house? Who is in the house?
me.
I don't think it's only you. Hello, Lauren. How are you doing? Izagu. Izagu.
Hello.
Hi. Good evening from
Yeah.
here.
Yeah. Good evening.
How are you?
No, I'm doing good. How are you?
I'm great.
Okay.
Where did you tune in from? Where are you attending from?
Botswana.
Oh, that's great.
Yeah.
Wow. Okay. Welcome, and it's nice to have you. Hello, Mr. Farah.
Thank you for that. So would like to thank our sponsors for the meeting, Biotech Quantum Technologies, for sponsoring us and helping us get this platform running and to be able to host these meetings. So a little bit about One Quantum. So One Quantum is a local One Quantum is a local is a group for local communities globally to foster joint success in quantum tech. So we are built on mainly 4 pillars, which are communities whereby an example is this meeting that we're having, whereby we meet and we form relationships and we have a community gathered. We also have mentoring. We currently have a mentorship program that is running in conjunction with Keysight Technologies. So we have mentors and mentees. So I'm fortunate enough to be one of the mentees, and it's a very good program. I've been learning a lot quantum-wise in so many areas. So it's a very good program. We also have careers. So we have a database where we have resumes. So it's good for job opportunities that so we've had others get employed through our platform where we have those resumes. We also have projects. So we have projects that have been run on real we have real quantum projects that have been run making use of the StrangeWorks platform. For example, One Quantum Nepal is doing just that, and they're having some projects that are ongoing. So One Quantum has been fortunate enough to have had so many speakers from all parts of the world. So this is just a picture of the speakers we have had from different countries: Africa, Europe, Asia. So many people I cannot name them all, but trust me, we're a very broad community that networks a lot, and we also have from One Quantum Africa, we also have our local chapters. So we have One Quantum Libya led by Abdul Malek. We also have One Quantum Zambia. We have One Quantum Ghana, Nigeria, Rwanda, Ethiopia, and Zimbabwe, and it's still a growing community. So far, these are the local communities that we have in those countries. So if you belong to any of those countries, feel free to reach out, and you could have a quantum community a walkable distance away from you. Moving on to our speaker for today, it is an honor for me to introduce you to Karan. Pinto, who is the head of growth and product at Terra Quantum. So he's a world leading services company offering algorithms, compute, and safety today. So at Terra Quantum, he focuses on unleashing their rich quantum IP to tackle the world's most important challenges and build high value applications across sectors for near-term advantages. So I will not unpick all that he has, but I'm sure he has amazing things to share with us. So it's also co-built in Tango, an open and global quantum technology community platform powered by the Quantum Daily, which is amazing. At Intengo, the pursuit is to humanize and make real quantum. So through his previous job as a senior venture builder, he helped companies make breakthroughs through great opportunities happen through business model innovation and disruptive technology commercialization. So we are very happy to have you, Karan, here, and we are looking forward to hearing from you. So with that, I'll stop sharing my screen. And then you could
Thank you. Lovely. Thank you for that, Karan. Very nice. Thank you for telling me all about One Quantum and what you guys are up to. I think it's really cool to be here, and I've got lots of exciting things to share with you guys. So, I hope to kind of, have a more of a discussion with you guys rather than just me kind of presenting in one way. So feel free to kind of pop in and ask me questions at any point. But I think if you give me the ability to share screen, I will get started. I think you've given that.
I have, please just check. I have given you the rights to share your screen. So
yeah, that's coming up. Give me a second. And you can see my screen.
yeah, we can see it.
Cool. So the title of today's talk is called "Thinking with a Quantum Hat," and the motivation is to really kind of help you unleash quantum for practical applications, and a little bit about kind of what I plan to go through. For some context, we all know that quantum will be game changing, and it will be game changing if we find the right applications for it. Though finding the right applications is really hard. And the objective of today is to help you understand the tools, the techniques, a little bit of principles on how you could potentially find the right applications. I'd like you guys to think about applications as we go through it so that you can share that with me, and then we could, have a bit of a brainstorm session at the end. The idea today is I'll start off telling you a little bit about myself and some of the organizations I'm affiliated with. I'll touch on quantum on a very, very high level. I'll share with you some application frames to help you think with a quantum hat. And then I'll take you through a process that we have at Terra Quantum and that I've developed over the past 4 years to actually find quantum applications or ways in which to demystify this art, which is more than just a science. And then I'll leave ample time at the end for you guys to ask me any questions, but feel free to kind of get off mic and ask me any questions as we go along. So starting off, like a little bit about myself, like like my interests lie in the intersection of these circles. That I really like venture building and innovation. I like creating new companies and anything that's to do with disruptive tech and innovation. Quantum technology is going to be one of my main focuses over the next few decades. I really like to invest and find opportunities from a value investing perspective, but really think about sustainability as a really important growth theme. And the greenwashing element is something that I've been investigating deeply for the past 2 years. And on the fun side, I really like contemporary dance and movement and mindfulness, and that's how I like to spend my free time. In terms of the organizations I'm affiliated with, so I'm head of growth and product at Terra Quantum, which is a quantum services company. I run Entango, powered by the Quantum Daily, which is an open, free, global quantum technology community platform, which I'd love you guys to join, which is the whole pursuit of which is to demystify quantum, And lastly, I also co-founded ADIS, which is a think tank that focuses on understanding disruptive themes that will impact tomorrow. So a little bit about the companies that I'm affiliated with. So Terra Quantum, at Terra Quantum, we do three things. We offer quantum algorithms, compute, and safety as a service. And this is our pursuit to kind of help solve some of the world's most important and challenging problems through offering an end-to-end quantum service. And a big focus of ours at Terra Quantum through these three services is really finding practical applications in across industries that would benefit much from quantum technologies. And that's the whole pursuit. And that's what that intersection there that you see is something I want to kind of demystify and drill into to make real for you guys. At Entangle, like the idea and the pursuit there is to really bring together the entire quantum ecosystem. And some of the stuff that you guys are doing at One Quantum is exactly that. I think it's in the same direction. But there's so many other parts and puzzles of the quantum ecosystem. You know, you've got folks at corporates who are looking to find applications. You've got people who are looking to invest capital in good applications and technology. And you've got academia who's, you know, just charging through with great scientific inventions that is fueling all of this and leaves with us a plethora of IP that is waiting to be commercialized or used practically. And so at Entangle, what we try to do is really do three things. One is simplify quantum jargon, really go away from any kind of prerequisites that are required to understand why quantum is important and think about quantum generally. Second is demystify where opportunity and value exists. And three is share industry insight. And industry insight is rare because everyone's trying to push a certain agenda and it's hard to see what is actually true. And in the pursuit of that truth, we created Entangle as a neutral ground. And then lastly, just to finish up on me, I also enjoy very much finding problems and building things. And I've been doing this for the past 10 years across multiple ventures that I've worked on. And I use ADIS, which is a live collective second brain. And you guys can explore it there. And I'll share after this call where, you know, I continuously try to learn about new niches and spaces that are outside my circle of competence, such that I can keep expanding the way I think and find new interesting things that would be in domains that are worth exploring. So now moving on to quantum. So I guess you guys have heard a lot about, you know, quantum mechanics, but the heart and soul of this is about quantum powered technologies. And you can think of quantum mechanics as the most fundamental model in which, you know, physicists, mathematicians, engineers, and scientists use to kind of decipher our understanding of the world. And you could break down the meaning of quantum mechanics, and ideally, quantum technologies looks at bringing us really close to the way in which Mother Nature actually works or operates the universe. Now, if you think about it very simply, I like to use this analogy, right? On the left-hand side, you've got a candle. Like you could think of a classical computer that you have today as a candle, right? You can, there's only so much you can do with the light of that candle. And there's only so much of wax you can add to the bottom of that candle to make it, you know, brighter or improve it. On the right-hand side, you have quantum, you have a light bulb. So what's happening right now in the whole computation space is there's this massive transition happening where people are building the first ever light bulb. And now the question is, okay, how are we going to use this light bulb, you know, practically? So it's important to think about quantum as a fundamentally kind of different way from the ground up that has been created. That is a paradigm shift in the way in which we actually go about solving problems. And so I want to dive a bit deeper into quantum to like demystify that for you guys, and then we can start talking about the application elements of things. So if we start off really simply, like on the left-hand side, you've got a classical computer, which you could think of as, you know, bits as being as a switch. You can go to 0, 1. It's very discrete. It's deterministic in nature, and it's called mutually exclusive computing. On the right-hand side, you know, if we talk about quantum, you could think about it like more like a regulator or a light switch dimmer, okay, where there's like infinite possible settings that you could have, or you could think about it as superposition. And once it's measured, like it gives you like a switch-like result. And the ability to, or what makes you do this or enables you to do this is the basic unit of information, which is qubit. And this is the heart and soul of non-deterministic computing. But the beauty about it is that it can hold complex numbers, and it can, exist or allows the existence of multiple states simultaneously. So if we drill a bit deeper into this, right, we could think about superposition as like this intermediate state where the outcome has not yet been decided. Or I like to say it's like a linear combination of 0 and 1. And once you measure a superposed state, what happens is that it leads to decoherence, and you lose this rich qubit of information, because it becomes like a 1 or a 0 with a certain probability, which you then can use. Now, if you think about how we interpret information from a quantum perspective, firstly on the classical side, you could think about these qubits or these switches connected to each other. Okay, and there's only so much of connectivity that you can have there. There's only so much of complexity that you can model. And in some cases, you can actually get better precision and latency over quantum, but there's limitation that exists in terms of how much you can push a classical from a connectivity perspective. So on the quantum side of things, what you have is like, these dimmers or these multiple switches. Imagine them kind of connected to each other. And what happens is that, Einstein calls this as spooky action at a distance. That's how he kind of, talks about entanglement. And it's just fascinating because this just lets you kind of model complexities that you could not, model before. And this really is revolutionary to make real entanglement for processing information. And then lastly, if we think about the way in which, parallelism comes into play here, like, mostly classical computers look at stuff on a fundamental level sequentially, and quantum computers to a certain extent have a level of parallelism, which is much debated. But the idea here is how could you intrinsically exploit the ability of a quantum computer to find good, useful answers or find a way to a solution. And so if I simply like try to summarize, like, what quantum computers enable us to do is in some way, we want to control probabilities, and we can control probabilities through amplitudes in a quantum system. And these amplitudes, they're manipulated by certain things called as quantum gates. And you could think of these quantum gates as ways in which we could, manipulate these amplitudes, but they're just like a sequence of a deterministic sequence of matrix operations, or like manipulations of that qubit. Now, what happens is that these sequence of quantum gates actually leads to a summation of these amplitudes, which we use to create interference. Now, interference is actually what helps us build, or we base quantum algorithms off to find useful answers. And so, we tailor these quantum algorithms, which is the whole pursuit now, is for specific applications that are linked to particular problem types that you could use or exploit this quantum computation capability for. However, like building quantum algorithms is a real art. It's hard. It's not an easy thing to do. And what we need to keep reminding ourselves is that, how can we do this given all of these challenges of like measurement imperfections, decoherence, and control errors? But this is like a simple way in which you could think about, quantum mechanical or the magic of quantum mechanics linked towards practical applications driven by quantum algorithms. Now, if I just try to simplify now and move a bit on the higher level, to talk about frames in which you could think of quantum applications. There's 4 buckets in which you could think of, how quantum could help you. Okay, you've got on the left-hand side, you start off with, some of the really complex computational challenges, where we've got the prospect of solving them. And I say prospect of solving them exponentially faster, because you need to be mindful of, the conditions in which you could get these speedups. which are highly specific and depend upon the certain instance that you're exploring. You've got instances where you can find more optimal answers to problems that we can only solve suboptimally today. You've got the ability to simulate physical complex systems or dynamically changing or stochastic systems with much greater accuracy. And in most cases, simulate coupled systems that we've never been able to simulate before, just because we haven't thought about it from a quantum mechanical perspective, or just because we've not had the tools to be able to do that. And then the most exciting one, which is I think I want to empower you guys with today, is new applications, right? Like these are applications where people have not even thought about them because they did not have the ways of thinking about quantum or the tools or the machines to be able to test, experiment, build, evaluate, and scale applications. And that's what's happening in the quantum space right now is, people are in pursuit of these applications that could be the next Facebook, Google's of tomorrow, considering like now the internet is just being built. So I really want to get you guys to focus on these applications and think about these applications deeply. So if we talk about like problem types, right? So there's a number of problem types. The most mature one being optimization. Okay, where this is optimization problems where you're trying to find the most optimal answer given a set of constraints and criteria, and there's a range of variables that you're trying to cater to. And this could lead to kind of combinatorial optimization, which I'll touch upon in a second. You've got sampling and simulation problems. Simulation problems really important. This is like, looking at future projections of things, looking at how a complex system actually behaves to be able to model that system and evaluate what the most likely outcomes could be. And you've got so many simulation related problems for design, for molecular simulations and such. And then the last bucket, you could think of it as machine learning and cryptography. Machine learning, how could we create more intelligent systems with better generalization and learning capacity than we have today, and really augment the way we have neural networks, for instance, and hybridize them. And then lastly, you've got the cryptography bucket, which you're very strong at Terra Quantum, which is how could we have quantum safe encryption, or like just safe ways for us to communicate amongst each other and store data. And these are like the five main problem types, which you should keep referring to. Think of, okay, can I find an application in one of these problem types, or does an application I'm thinking of relate to these problem types? And it's not always like a one-to-one mapping. You could have an optimization and simulation related approach that come together, or black box optimization is mostly like machine learning approaches that come together. So there's a combination of how these things actually map towards an application. But if you think about it more deeply in terms of like, what is the nature of these applications that you should be looking for, right? There's certain aspects that make problems really classically challenging. And, the scale of the problem, the non-convexity of it, the non-linearity of it, which means, it's hard to kind of deal with the size of that problem because of, and this could be caused by either there's a lot of uncertainty that the system's creating for the problem, or there's a high demands, right? You want to solve this problem more frequently, or you want to solve this problem really, really quickly. So all of these aspects on a high level create a very complex problem space where it's hard to navigate, or it's hard to find the right answers, or that it's hard to configure what the best solution might be like. And just giving you guys a bit of an example here, right? If we talk about an optimization problem, say you have a knapsack, and the goal that you have is that you have a set weight that you can keep in the knapsack, and your objective function is you want to maximize the value of the items you put within the knapsack. Now you can only take a set amount of items, and each of these items have a bit of a dependency on each other, right? So for example, if you put the fire and the tent in the same knapsack, well, the fire is going to burn the tent. So that's a negative kind of dependency. But if you put, for instance, the fire together with the cooking material, that's good, because you could potentially cook a meal with the fire. So if you think of these dependencies, what happens is that as the number of variables increase, or as the number of options increase, and you considering these dependencies given the constraints, which is the weight, the value of maximizing the value of the knapsack, you get this thing called as combinatorial explosion. And combinatorial explosion is really beautiful. It's something which makes really simple problems really, really hard to solve. And and this is something that is, very contradictory to what people might think, which is, a few pointers on that. Like, problem size is not always something that drives complexity, right? It's not always like, big data problems are a great fit for quantum. Well, I think second thing that also, if you increase uncertainty, frequency, and non-convexity, okay, this really makes a problem complex. And dealing with the complexity is so hard to do today from a classical perspective, that people are really looking for solutions from a quantum perspective that could help with this complexity. And as I said before, like, fewer variables and a little data can also make some problems intractable really, really quickly. So be hyper aware of that in terms of, your search for applications and problems in this space. Now, if I give you a frame of reference in terms of how to think about quantum from a very simple perspective, how it sits within the stack, the end-to-end stack. This is a really nice diagram I like to share, where on the right-hand side, you've got, existing software and existing hardware. And this is the whole suite across the board, okay, that gives you capabilities to solve specific applications. What quantum is doing is it's bringing this completely new dimension on the left-hand side from a software and hardware perspective, okay, that is going to give you new capabilities and enhance your existing capabilities of doing things, okay? And this is a really nice frame of reference to think about, okay, how does the applications that we have today in terms of solving problems, let's say in optimization, how is that going to evolve? Right? There's existing capabilities that are powering these applications today, and there's new capabilities that quantum is going to bring. But how do they kind of interface with each other and evolve? Is a very important question in terms of dealing with the accessibility of the advantage that quantum can create for a specific application, and the pursuit and the pursuit here is, how could you get the best answers that is in some way agnostic of the hardware? How can you not worry about the hardware that's on the bottom of it that's powering it, but how can you get the best advantage on the top that helps you find the best solution in the time that you're looking for it in? So that is a bit of like frames of reference to help you guys think about quantum applications. So I'll just continue and finish this section, and then we can take questions. Okay. Sorry, give me a second. There's some water. Oh. Okay, so I wanted to give you guys a little bit of a formula to think about in terms of how you can find a great application. And so I think number one, it's important to find this application, which I say is super niche. It's either an unmet need, a need that a customer or a client or a sector has. It's either like a limitation, like they can't do something fast enough or complex enough or accurately enough, or it's a possibility in a high value growth space. Okay, this is where you could potentially find the application. Second is you have, the quantum algorithm or the hybrid quantum algorithm. This is what you actually do to be able to tackle that application that you find. Now, this needs to be scalable and evaluated very thoroughly. And mostly, these are like heuristics today, which the performance of which varies depending upon the hardware and varies depending upon the data and the problem instance and such. So it's very hard to comment on where advantage is most generically. And then lastly, you want to make usable the benefits. So you create some benefits through that algorithm. Okay, you want to make sure that these benefits are explainable, they're differentiated, and they're also accessible. And accessibility is a really important topic to be able to access or use these benefits in a commercial or industrial setting. And all of these, combine to a high probability of upside of finding a great quantum application. So how do you actually go about how do you actually, what's the process that you go about to do this from scratch? Okay, I'm going to take you through that. So this framework is a really nice mental model to have, and I call it like a how to do a where to what. Okay, this is, you start off where you're collecting dots, so you're collecting information, you're diverging, you're moving far away from what you know. You then have sufficient dots and sufficient knowledge, and what you try to do is you try to connect these dots, or you try to converge. And once you make sense of things and you're like, okay, I've got enough information, I'm now trying to emerge, I'm trying to like release this application to the universe and make sense of it. So what does this actually mean, and how does this actually go ahead in reality? So I'm going to take you through a process that I built at my previous companies here, partners, and it goes something like this. So we start off by getting inputs from the company that we're talking to, and there's different lenses that we use there, both qualitative and quantitative, to really kind of find out what they care about in terms of the problems that they want to solve. We then give them some kind of stimuli to help them kind of start thinking from a quantum lens and develop high-level hypotheses that can help us find a way in which we can find this scaled POC candidate that we're working towards. We then move ahead and we do this really rapid iteration loop with, let's say, low-touch feasibility that's highly informed by potential fit from a problem type, a potential indicator of advantage, as well as kind of data analysis perspective. So we want to make sure that the data is not only accessible, which is important, but also the quality of it for a particular problem is sufficient, and we can do something interesting with it. What this leads to is, it leads to a certain kind of validation, refinement of the application that we propose. And all of this is, goes through a fruitfulest prioritization process, because you want to make sure that you're thoroughly investigating this application that you're going after. And all in all, you want to propose this application together with a sense or a proof of performance for that specific application to move this on from a scaled POC. And right now, what everybody's trying to do is find the right proof of concepts to run with customers. And most of the proof of concept are on toy problems or like very small problems that have no practical use in industry. And like our idea is to actually find scaled POC candidates, which we can put into production live, that have hybrid quantum algorithms driving that. And so if I help you understand what is this criteria that helps you prioritize, so there's a few boxes that you want to tick. You want to make sure that it's in a high value application space. You want to make sure that there's some indicators in the literature of speed ups for that problem type or for that specific domain. You want to make sure that you've got good data of a particular quality that suffices. You want to make sure that these benefits, even after you create them, if you create a 10% or a 30% or a 40% advantage, will this advantage actually be true if you have a real world constraint that is accounted for there in terms of either the processes or the systems that this needs to be accounted for in, and you need desirable scaling. So you want this algorithm to be able to scale given the maturity of the hardware or the state of the systems today. And that's really important there. And so, just coming from a background of championing quantum commercialization, there's this, combination of finding this unmet business need, having application advantage, which is better than the best in class classical technique for that business is using quantum IP of the quantum startup, and having the right business model that's useful for creating that IP to be accessed. And so, you could think of this intersection as, it gives you a high value outcome and gives you a competitive moat when you find these right applications in the right spaces. But it's not always it's not always clean cut. It could be outside here, and it really depends upon the specific instance that you're searching for. I wanted to give you guys one example. So one example that from a quantum commercialization perspective that I worked on in the industrial space, which we found like an unexplored opportunity space, and just showing you how we found an area to innovate and find useful applications. So this is what I call ask a why continuously till you actually get to a what. So here we asked, okay, why is industrial manufacturing actually unsustainable? We ask why again. Well, because it releases toxic gases and wastes 4% material. But why is that? Because the process is filled with transient combustion and overcompensates with energy. But why is that? Because you need to control the furnaces driving this with greater fidelity. But why is that? Because the burner schedules are hard to solve optimally given time restrictions and scale of the problem. Okay, what does that mean? Well, that means that you could have a burner schedule optimization problem that you need to integrate within existing workflows. That is where the opportunity lies. So as you can see, the opportunity is not very clear on the first layer, but if you continuously keep asking why, you eventually get to a what related situation. And so just to give you a little bit of color, like, across sectors, like most corporates are, or like people trying to adopt quantum are like either experimenting or exploring the space. Very few are very highly mature and using some of these hybrid quantum algorithms in production. But the pursuit is to push application and scale adoption of quantum in a useful way. And so, like, we understand, like, to be able to do this, it's important to kind of drive adoption beyond proof of concepts. And to be able to do this, you need to progress on both a business and a technical perspective. And so you can't only consider the technical application readiness levels or the TA RLs that has been derived by NASA and is a useful metric to understand how mature is the technical feasibility and of your or the maturity of your application, but also the business aspect of things. And like these two are inseparable and they go hand in hand, and we need to consider both these lenses when we're trying to push adoption favorably for us. So so that's basically what I want to talk about. I'd really like if now we could you guys could think of like some quantum applications, and I'm here for any questions. That was all I wanted to share. Thank you.
Thank you so much for that amazing presentation. I'm sure there are a couple of questions in the chat, so I think I'll just ask the people, write them down to ask them if possible. I saw Daniel had a couple of questions, so Daniel, if you could unmute and ask your questions, we are all ears.
Sure. I think so I think the first one was, have you generated the revenues for the start? Yes. Yeah, I think I've been working on these over the kind of past 10 years, and I think that's Daniel Madhu. Yeah, I think I love kind of solving problems and then creating the right business model around it, and then releasing products into the market so that people can use that, whether that's personal butler service or like a marketplace for art. I think I'm very much kind of about finding something interesting and worth solving for, and then looking whether you could kind of release that and go to market with it and make a profit off it. And that's what brings me to Terra Quantum as well. Is this, we are trying to build the deep tech pioneer of the century, and that's highly exciting from a startup perspective. Interesting, leading a community from your country. Second, Daniel Madhu, the activities in the neocortex is so stochastic. Can we simulate that part of the brain? Oh yes, that's really interesting. Again, Daniel. So Daniel, I think what's most interesting from a brain perspective is potentially neuromorphic computing or neuromorphic chips, and I'm guessing I think that's something worth reading up on. It's we ideally, once we have an NPU or neuromorphic processing unit, it'll be nice to kind of integrate that within our QML architecture as well. And that's when the brain machine interface comes through. And there's a lot of work that Neuralink is actually doing on that part as well. But yes, it is highly stochastic, and it's a complex system to model. And that could be an interesting one to kind of look at. Yeah. How do from Abdul Ali says, how to simulate electronic devices using quantum computing techniques, like in a classical computer when using TCAD. Could you kind of explain that a bit? Are you here? I actually left the call. Simulate electronic devices using quantum computing techniques. Like I don't understand that question. Sorry. Access the recording of the event, made it accessible. Okay. A lot of thoughts. Daniel Madhu says, given that there's a lot of data about the current state of the climatic conditions on Earth, and there is a mission to net zero here upon us, are there any ways quantum computing can impact this problem? Yes. Are there any framework people can account for? Yes. So actually, so Daniel, are you here? Are you on the call? Yeah, there, Daniel. So yes. Daniel, yes, yeah. Oh, yeah, great. I think I actually I wrote an article on this for Tech UK recently, which is I can just share your chat on climate change and like the quantum impact of it. I can just talk you through that as well. So there's actually a really nice initiative that is worth following as well, called Climate for Quantum for Climate, which I'm sharing in the chat for you guys. But also I wrote an article for Tech UK on this, which I will share with you, which explains really nicely the impact of quantum computing and quantum technologies for climate change. But if I summarize it for you guys, like I think there's a couple of buckets there which are highly interesting. So firstly, it's like the simulation of physical systems or complex physical systems, like whether that's batteries, to understand degradation and how that unfolds to influence material science related decisions, highly important for EVs as well as for grid scale energy storage. So that's one. You could also think about material science more from the perspective of how do we decouple renewable energy machines like solar panels and wind turbines from fossil fuel related materials. So we need a lot of innovation in that space. So I think that's something that we need to think about deeply. So that's one. I think two is like more like computational efficiency. So like, like some of these highly computationally intensive workloads that we have that are solved classically, okay, that cost millions and like, our data centers power through. Some of them could be good candidates to evaluate to have as subroutines on a quantum system, and those could be efficiently solved, and that could be a good way to think about kind of efficiency computationally. So I think that's the second one. I think the third one is like around combinatorial optimization. Combinatorial optimization problems in logistics, for instance, like supply chain logistics across the system, or like more practical kind of last mile delivery. Like those, we can have fewer empty miles driven by trucks, which bring your Amazon parcel to you, or just deliver groceries to the supermarket. So those things are happening every day, and like we can optimize on some of the stuff. So that's just a few examples. I can talk for days on the quantum X climate change intersection. Did I answer the question, Daniel?
Very well, you did. You did answer them very well. Thank you very much. And I'll be delighted to read your articles and also connect with you on any platform that you find yourself. You really answered all of them very well. Thank you. Thank you.
So I think you're okay. Then you asked another question, which is, are there any quantum computing algorithms that can impact the complexity of grid? What do you mean by that? Do you mean the energy grid? Or what do you mean by that?
Yeah, what I mean by here is, there is this idea that a startup is working on here, being able to decentralize smart electricity. So, the complexity of that grid would definitely increase when more households tap into such grid, like kind of a decentralized solar electricity using smart metering. So
Yeah.
I don't know if
So,
there is a way quantum.
yes, so many, like so many. So I've done so much work in that intersection again. So the way quantum will impact the energy systems is there's so many applications there, right? So if you think about it fundamentally, like you think about the whole grid, right? You've got generation, you've got distribution, transmission, um, and supply, right? Those are the main components of your value chain of your energy system, right? And what's happening in the energy system is that the composition of it is changing dramatically, right? For instance, like each of those components have different things in them. So for instance, you have greater renewable energy in the grid from solar, wind. Right now it's changing the nature of generation. You've got more battery capacity in the grid, at different points, to either service kind of for ancillary services to basically support the grid to make it function smoothly, or to store some of the renewable energy when there's no demand, when there's renewable energy that's created, so they can use further. So what all of this is creating a lot of problems that are very fundamental and need to be solved. And I think I can highlight a few of them, right? So for example, one of them is called optimal power flow, OPF, optimal power flow problem. That's a very highly important problem. It's very complex to solve. I think it's NP hard in nature. It's something that's solved every 5 to 15 minutes in almost every power grid in the world, right? This just makes sure that the right amount of power is flowing through the grid, such that the light in your house can come on based upon the amount of energy that's generated right at the start of the system. So optimal power flow is a really important problem. There's another problem called as a unit commitment problem, which is more generation based. So it's like, okay, how could we best use the generation capacity that we have to generate in the most sustainable way possible? And this is an important and a complex problem because it's very hard to put off a coal powered or natural gas powered power plant. You can't just put it off, and it takes a long time to come on. And it's more efficient when these things are running rather than, and that's funny, right? It's more efficient when these things are running all the time than if you put them on and off. So you need to really think about when you need to put them on and off, and also think about, the granularity in terms of, producing power, for a specific time frame, and the uncertainty that comes from renewable energy generation. So unit commitment is another interesting problem. And then the last one I'll maybe touch on is like congestion management in the grid, right? So for instance, like all the smart grid related problems like depend highly upon like a great amount of great congestion management. So this is everything from having the right voltage regulators and capacitors in the grid at the right points, and kind of the configuration of them to more let's say to more kind of like balancing mechanism, like problems over there. So I hope I answered that question. Great. I think.
Okay,
Okay,
if I could,
sorry.
if I could
Okay.
also come in. Oh, okay. Who was? No, it's okay. You can. I can be the last one to ask. I don't mind.
Okay,
So
thanks. Thanks a lot.
Sure, Kenneth.
First of all, I just wanted to thank you, Karan. Like the content you've shared today was really amazing. I'm really glad I attended. I saw the material you shared concerning how cryptography, the role that quantum has to play with cryptography. But I wanted to find out, as Web 3.0 is rolling out, is there any way you think quantum would impact it? And do you know anything concerning consensus mechanisms, or any way that quantum will play a role in developing consensus mechanisms?
Yeah, so I can answer that question generally. So like, yeah, so firstly, like if you look at the crypto system that we have today, which are like symmetric and asymmetric crypto systems, or like asymmetric being public key cryptography, both of them have certain kinds of vulnerability to fault tolerant quantum computers of a certain extent, right? And they need lots of there's different numbers of qubits required to break different types of encryption systems. but they are vulnerable. They're vulnerable because, like, most of them are based upon solving, either the discrete logarithm problem or a prime number factorization, right? So the only ones that are in some way free of the threat are the ones that are, some of the ones based on like elliptical curve cryptography or, one-time pad encryption. And some of them are, which are purely based on information theory, are like in some way quantum safe, but you need to investigate that deeply. So there is a threat, yes, and that threat is real because you can save data today, and once quantum computers are ready, and they might not even tell you when quantum computers are ready, because they might have a quantum computer in secret, and they can decipher that information. Now, when it comes to like consensus mechanisms and like which are the heart and soul of like the great kind of DAOs or like blockchain powered applications, I think the important thing there is to understand a couple of things, right? So firstly, like most of the blockchain related applications have public key cryptography, right? So your public key is accessible. In a quantum fault tolerant quantum world, that is highly vulnerable, right? You could use your public key and figure out what your private key is by working backwards. So that cannot work. So there needs to be a change in terms of the quantum systems, the kind of, let's say, the quantum powered security that blockchain systems have. And one thing to be mindful of is to be very careful about when people talk about post quantum security, to really look at what do they actually mean by that. And like, it's very easy to say that you have post quantum cryptography, but when you look at the literature and you really look at what's being done, you'll still find vulnerabilities in what they're kind of doing. And so you need to ask the question of, okay, what is the way in which we could have unconditional security? And that's the pursuit, right? How could you have unconditional security, which does not depend upon, whether a fault-tolerant quantum computer has, I don't know, 1 million qubits or has, I don't know, like, 10 million qubits. So that is the pursuit. And I think we've got some solutions at Terra Quantum which are interesting for that. But I think, the blockchains of today will eventually definitely move towards a quantum security powered solution. Yeah.
Yeah, thanks a lot. Yeah, that really helped.
Okay, Karan, I was going to say to you, I think a few questions that I have. Given your great visibility of the ecosystem, may you please comment about what is happening in China? We don't get to hear so much. I only know there are publications that come out once in a while claiming, that they may have the best quantum devices at the moment. They are breaking records, especially challenging Google on quantum supremacy and everything else. So I would want to know about what's your comment about progress happening in China in terms of quantum tech. Even perhaps like you said, even now when you were answering Kenneth, they could already have a quantum computer and are not simply announcing it.
Mm-hmm.
And it's possible that people can develop these capabilities and not announce them, given the security aspects and all the other things they could be using the technology to do. Secondly, would be I want you to comment on what you think is the best role that Africa can play. We haven't been talking of any hardware so far. It may be far off the line. And I'm just wondering, from your vantage position, what you think we should be concentrating on, what could be the thinking process we have to go through in terms of looking at the SWOT analysis that allow us to zoom in on something that we can be good at and perhaps maybe the best at in the ecosystem. Yes, perhaps take those two and let's see what comes out of it.
Okay, brilliant. So on the first one, right? The first one, I mean, I don't think anybody will ever comment directly on what's happening in China. That's a bit controversial, right? So I won't comment on. I think one thing that's interesting to look at though is like, in simple words, like look at where the money's flowing, right? Like, and you look at the capital that China puts in. You could in some way correlate progress with capital, because this is highly capital intensive. Is to building quantum computers is no easy task. You're going to fail a lot and multiple times, but you need to push ahead, and the most amount of capital has a high chance of winning, right? And also we need to be mindful that China could be doing things that we don't know of. And I think, that again comes back to the question of, quantum security and some of the moves that China's made in terms of even, the transition towards restricting the amount of time that the children can spend on, apps like TikTok. Their own children, Chinese people, can spend on these apps. Just kind of shows you how they understand the risk associated with their applications and are infringing kind of restrictions on their own people to keep them away from that. So that's maybe, keep that in mind every time you download or get onto TikTok or something like that. So I think that's on that topic. And I think on the second topic around what Africa could do. So I think like the coolest thing that you guys could do, like personally, like each of you here, right, is if you want to get into quantum, is set up like a bit of a, let's say, I think like a quantum apprenticeship program, right? So for instance, right, get 3 or 4 companies, big quantum companies, small quantum companies, okay, a consortium of companies, and have a group that runs over, like, let's say a year, that goes through, a shadowing process. Like, you meet these quantum companies together over a year, and you do everything. You start learning to get hands-on with quantum algorithms. You learn about the hardware that they have. You learn about their pursuits, their challenges. You learn about kind of aspects of the business that you could be part of. And I think if you guys can set up like an apprenticeship scheme, what that does is that and you get the model right for that. What that does is that solves a very important problem for a lot of quantum companies, which is talent, right? And the problem with talent is not actually like everybody says, okay, it's quantum physicists, we're lacking quantum physicists, or we're lacking quantum scientists. Yes, that's true to a certain extent, but what lacks a lot is it's very like it's a bubble that we live in the quantum world, and like few people understand this, right? It's a bubble you live in the quantum world, and for someone who's completely outside to get in, it's really hard. It's really, really hard, right? It's really hard. They don't know where to start. It's like, who do I, and also the knowledge gap is humongous. So the best thing to do to bridge that, I think, is to actually start like an apprenticeship program or like a shadowing program, where in some way, like, you could gather, I don't know, like a group of highly motivated people who want to build or do something interesting in the quantum space somewhere in the future. And it's like, you get these people who do like 2 sessions or like 3 sessions a month with 2 or 3 companies. And in some way, the companies build a familiarity with the people, and they understand where their skills lie, and then they get them, they give them skills, and I think that could be really interesting. And then that results in 1 or 2 people getting hired as I don't know, like an intern at one of those companies to do something. And that's cool, right? Because then you guys can go work in different parts of the world, and virtually or like there, and or you guys could be part of a team. So like, yeah. Anyway, I think that's some ideas. Yeah.
Oh yeah, I was going to say thank you for that.
Great.
Sounds good. I think I would give it up to Lorraine, who's running the session, to take us to the next level.
Thank you. So, Karan, I would like to take you through our lightning round. So I'll just ask you a few questions, and I would want to hear your shortest response possible on these questions. So the first one is, what do you think is the biggest misconception about Africa or its people?
Biggest misconception. A misconception about Africa or its people. That you can't dance. You guys dance so well. I think you guys are such good dancers. I did an Afrobeat piece when I was at university years back, and I was amazed. Like the dance is just next level. Like the rhythm and the feel and the beats. So I think that's the misconception. It's like African dance is not cool. It's the misconception.
Oh, that's interesting. Thank you. Which book are you currently reading outside quantum tech and physics?
What's wow. I'm reading actually Alice and Bob Meet the Wall of Fire. It's a science book by Quanta. It's amazing. It's great. I'd buy it. Alice and Bob Meet the Wall of Fire. It demystifies some of the biggest questions in science being addressed by cutting edge physicists and scientists, and I think it's really good read, really nice. It's simple to read as well. But I think what the reason I'm reading it is because I think there's a lot that happens in laboratories across the world which we don't know of, and it's very important to kind of us, like people like me, to understand the way in which these people think what they're doing is great, such that I can think in the same way, understand the language, and then talk in a very simple and relatable language to the industrial world, right? Where I can commercialize some of the great things that they're finding, or find useful applications for the inventions that they have. So Alice and Bob Meet the Wall of Fire is my recommendation.
Thank you. What is your favorite hack or simple tool that you think is underappreciated?
Pen and paper. Just use pen and paper. Underappreciated. Yeah. Like I think whenever you're listening to somebody, if you have pen and paper and you write something down, you understand it a million times better. You can be more useful in that conversation. And I think it's very humbling to write something down. So, and no matter who you are, where you are, if you write something down, you could always learn something from that. Whether it's, somebody you're talking to every day, or whether it's somebody you're talking to new, just the act of writing something down creates just as great a connection. This is really interesting because, we still haven't figured out great human machine interfaces, right? We're still, it's so inefficient, right? Right now, you and I, like the conversation we're having, guys, here is so inefficient. It's on a 2D, let's say a 2D shining rectangular block. Okay, like it's so bad, like I can't like interact with you guys. And of course the metaverse is going in that direction and such, and hopefully we'll all have avatars that we put on Facebook's things and stuff like that very soon. But like the connection between the way we think and the way we kind of output is really bad today. So like that interfacing is the best with pen and paper. So that'd be my simple hack.
Taking notes.
Yeah.
What is the best career advice you can offer to young people today?
What is the best career advice? I think optimize for interestingness, right? I think that's optimize for interestingness. I think not many people will tell you that. I think you like when you're starting off, like you think you need to understand where in the cycle you are, whether you're collecting dots, okay, which is you're diverging, which you should be open to every experience that you get, like every opportunity you get, till you can understand what you like, what you don't like, okay, and then you can then converge and say, oh, I don't like these things, I like these things, or I want to do more of that or less of this. And like I think people do that a bit too early, and so like collect as many dots as you can, be open to really experiences, and then optimize for interestingness, right? Go after what sparks your intellectual curiosity. Go after what kind of you want to kind of like, when your eyes light up when you look at that, or you're so interested by that, you're like, okay, this. And if you haven't found something like that yet, just be very open-minded, right? And I think the open-minded aspect is probably like goes hand in hand with optimizing for interestingness. If you're open-minded, what you can then do is you give yourself the chance of uncertainty and random experiences, right? So for instance, if you're open-minded to go to a conference which talks about like Web 3.0 without you knowing anything about Web 3.0, after you go to that conference, you're going to probably meet some cool people there that's going to open up new opportunities about them telling you about the way people are earning money by playing games in the metaverse. And then one day you start earning money by playing games in the metaverse because you went to that random conference that couldn't make sense when you were making the decision to go to that conference. So be really open-minded, and then optimize for interestingness, and then understand where you are on that cycle, whether you're collecting dots or whether you're actually, connecting dots or converging, or whether you're emerging. and accordingly, like, where you are in your life there, then the advice changes. But I think that would be my advice.
Yeah, what is your favorite getaway place in Africa, and where are you based right now and why?
You tell me where I should come to in Africa. I'll come. You tell me. I'll take a plane and come see you guys. Zimbabwe. Zimbabwe,
Yes.
yeah. I have a
Yeah.
friend actually in a really good friend of mine in Nigeria, in Lagos. So I think maybe that's my favorite place because I don't know anybody else in Africa aside from you guys, right? So yeah, like where am I right
Welcome to Nigeria.
now? Welcome to Nigeria. Yeah.
Welcome, welcome.
I think what you call it, what's it? Where am I right now? I'm in London. I'm in the United Kingdom, London. You're more than welcome to come see me in London. Yeah, I've been here for the past 10 years, and I like London. It's cool. It's like this middle ground between the West and the East a bit, and I think it's always, there's always interesting things happening, and there's always something to spark your wonder. And I think there's a quote which is really interesting to share, right? It's like I forgot who wrote it, but it's like if you get bored of London, you get bored of life, right? So I think I'm not yet bored of life, and I'm not yet bored of London. So come to London. Yeah.
That's amazing. We'll definitely do so and definitely visit you, and you can show us around. If we had a capable quantum computer today, what problem would you suggest it solve first?
What problem would I suggest it solves first? Oof, that's
Yes.
such a hard question. I think probably like a capable quantum computer. Like I think you got to look at the where best can we kind of help ourselves, right? And I think that would probably be molecular simulations, 100%, right? Like I think like if we can find cures to some of the diseases that are killing people day in and day out, where because of imprecise the blockbuster pharma model of medication, we're failing. Okay, whether that's Alzheimer's, it's cancer, that's chronic diseases like diabetes, where we can find wonder drugs there, or whether we can really push forward personalized medicine across the spectrum. So you're looking at everything from the genotype, the phenotype, proteomics, transcriptomics, metabolomics. If you can look at all those things and then find good treatments and drugs and therapeutics that can help people feel better and not die. I think that's probably the most important thing, right? We want people to live firstly and save people, and then we can save the world as well. So I think I'd go to save people first, and then we can save the world after that.
Thank you. So if people want to keep in touch with you, what is the best way to connect with you?
So the best way to connect with me, I will send you guys a link, which has a link to everything of all my links. So give me a second. Links. So if you want to connect with me, just get in touch on this link, and you can find all my profiles. So that's the best way to connect with me. I'll share it in the chat. Yeah, I want to say thank you to you guys for having me. I think this is cool. Like, if I can help anybody here, just let me know. Send me a line on LinkedIn or Facebook or like anywhere. I'm very happy to kind of help answer questions and support in any way I can. You guys keep doing this. This is really cool. I think I'd love you guys to join the Entangled community, which is is our heart and soul in terms of what we've been doing for the past few years. And I think it'd be great to see you guys there, and let me know how I can support One Quantum efforts and connect you with more people and make things happen. Let me know. Cool.
Thank you so much, Karan, for the amazing presentation, and thank you all guys for joining. I've shared a link in the chat to our cocktail party. Please join us for one-on-one networking. Would love to get to know more about all of you guys. So if possible, please do join us for one-on-one networking. And we'll definitely keep in touch. I might be having one last thing to say before we sign off.
Yeah, I guess so. I have to. So thank you so much, Karan. You know, we tried for so long to get to make this to happen. So thanks so much. And we saved the best for last, I guess.
Yeah.
So
Great.
yeah, and thank you everyone for joining. Thank you.
I hope you
Africa, for
enjoyed
the
that.
support.
I hope you enjoyed that, really.
For sure, that was great. It was amazing, and we couldn't have had it any better. And you know, it was nice to bring everything together, especially on the applications and just figuring out what are the important things to focus on and what should we do next. So yeah, this has been our last meeting in this form for the year. It's time to regroup, reflect on what we have been doing over the past year, and come back next year with a new, new activities and perhaps different format to this event as well. So yeah, and then we'll be very happy to contribute and be part of the Ntango community, and keep in touch with all the people who are working to develop a community to see how we move quantum forward in the best way possible, and to get Africa involved, to get people in the continent to have an opportunity and to just get to do this. So yeah, I think that's my word to you guys. Thank you so much for the support, and let's join the cocktail. Be patient with the link. Sometimes it is just interesting. But yeah,
You guys
try to use
take care.
Chrome and try to join us for the cocktail. Thanks, Karan. Let's keep in touch in other channels. And
Bye, guys.
always a
Take
pleasure.
care.
Bye-bye. Cheers, everyone. And thank you, Lorraine, for hosting this. Really appreciate it.
Thank you guys for joining. See you on the
Wonderful
cocktail party.
moderation, Lauren.
So you can pause